Hello, so this is the review class for test 2. And I made this review so that we could review all the major topics that we've covered up to this point that I would expect you to know for a test. And I wrote here that there's 10 multiple choice and 5 long answer. So similar structure to your first test. Your first test had 10 multiple choice, 4 long answer, but basically the same thing. You still expect to do half of it or part of it on Dropbox and part of it on the D2L quiz, but pretty simple really overall. Okay, well, let's get started. The first question is a review of Unit 4, which should be clear because it's amplitude, period, displacement, and that kind of thing. So amplitude, period, and displacement of the trigonometric function in radians. So two different questions. One is for sine, one is for cosine. But honestly, for this question, it doesn't matter if it was sine, cosine, or anything. So the amplitude here, you should hopefully remember that it's A, which is the number in front. So you just copy that, it's 1 over 3. I guess as a very quick review, A here is 1 over 3. B here is 3 over 4, it's the number in front of the x. And C here is pi. So we'll use those as part of our formulas to get our period and displacement. So do you remember the formula for period? It's nice to have these things memorized so that when you actually need to do them, you don't need to go through your notes. Does anyone remember what the formula for period is? I'll give you a hint. It's 2 pi over something.
Okay.
2 pi over b. Yeah, 2 pi over b. So that's 2 pi over b. A lot of students got this wrong on the test. Not the formula, but the division. Because I think what they did was they went 2 divided by 3 divided by 4 on their calculator like this. I think you can see that maybe. 2 divided by 3 divided by 4. That gives 1 over 6. That's not the right answer. Because on bottom, you have to consider that whole bottom piece as a fraction. That's why I write it slightly differently. So what it is, it's actually the same as 2 pi times 4 over 3, which is 8 pi over 3. So be careful with that. It's not pi over 6. Some students write pi over 6. That's not right. So 8 pi over 3. Let's do displacement. What's the formula for displacement? I'm just seeing if anyone is going to write it. It is negative c over b. Close up little, so yeah, negative. You're not expected to memorize these. You have done the formulas before, of course, so you can just go look them up. But careful. You should have these memorized. It's a lot faster. So negative pi, and then b is 3 over 4 again. Same story. And if you do that, you'll get negative 4 pi over 3. If I was to ask this, it would probably be a multiple choice question, and I'll just ask period or displacement. But if you know how to do all three, then it's easy, really. So the next one can be for you to try. Just try to do this. I'll do the amplitude for you, and tell me what you get for period and displacement, just to make sure you know what you're doing. This should be really fast. This one's just a little trickier because of the fractions. What do we get? Anyone brave enough to tell me what it's going to be? see, 2 divided by 2 over 3. So once again, let me show you very clearly, especially for anyone who watches this later, very, very clearly how I set up these fractions. So I'm looking at the period over there, 2 pi. I'm going to ignore the pi for now. I can always put it back in. So there's 2 ways. If you want to do it all in one line, if you do 2 divided by 2 over 3, that is incorrect. It's not correct because you're dividing 2 by 2 over 3. It's not, these aren't just, the brackets don't seem to make a difference, but remember, it's the difference between doing 2 divided by 2, then divided by 3, or 2 divided by 2 over 3, which is actually 0.66666. Anyway, there's a difference if you work it out by math. So be careful. It's 3. So you should get 3 pi. And I'm looking here. I actually got 3 pi. Let's see what we get for the next one. Oh, first of all, yeah, you can set up the fraction as well. 2. The problem is many students don't set up the fraction correctly. In this box on bottom, you need to set up your other fraction. You need to click the fraction there. And then we get 3. So 2 ways of getting 3. I'll write that in a second. For displacement, same story. You can set up a fraction here. It's pi over 2, so I need to set up another fraction on top. This one's tricky. Pi over 2. In my bottom box, set up another fraction then. 2 over 3. This isn't my favorite way to do these ones. So 3 pi over 4. That's what Abdullah got for the second one. Excellent. What I like to do, there's 2 ways. I'd set up a fraction like this, all in one line. 1 over 2 bracket divided by 2 over 3 bracket. And then I know there's top in brackets, bottom in brackets. Get it? You get 3 over 4. Same answer. Another way to do it is by hand, and there's 2 ways that I'll show you. First of all, we know the first one is 3 pi, yeah? 3 pi. On the bottom one, there's a few ways. I'll write one to the side here, which I'll erase. But pi over 2 divided by 2 over 3 is the same thing as multiplying by 3 over 2. This 2 over 3, it flips to 3 over 2. And that's really easy to see now. You can see that it's 3 pi over 6, or sorry, 3 pi over 4, which is exactly the answer that we were looking for. So the negative, sorry, not negative reciprocal, the reciprocal process is usually what I do. When I do this in my head, which is normally how I would do this, I would just make sure that I do the flipping process in my head. The other way to do it, which is a trick, but you know, depending on the students, they like this one more. You take the ones that are furthest away and multiply them. So pi times 3 is 3 pi. And then you take the ones that are closest and multiply them. 2 times 2 is 4. That's on bottom. So whichever way works best for you, but just be really careful when you're doing this that you don't get it wrong. That process, by the way, works for other fractions. The idea of taking the furthest ones away. So 2 pi, for example, in this first question, multiplied by 4 gives 8 pi. And then it leaves your 3. So different ways to do this, but I don't want you getting too lost in the tricks. I'd rather you do it, you know, with some logic behind it when you can, so that you can make sure that you're right. Okay, feel okay with this? We can move on. Yep. All right. Again, it's all review. It's nothing new, so I expect that you'll at least recognize it. But I'm just trying to give you that extra boost so that if you struggled with it before, you'll do better now. And if you lost a mark or two before, maybe you can even get 100 now. Right? I'm just doing what I can to help you. So what is the amplitude, period, and displacement of each function? Same question, but from a graph. So students find this one a little more tricky. Let's see what it has for us. So assume this is a sine function. Well, I need the amplitude. That one's easy. The amplitude is just how far from the center line, which is clearly 2. Yeah, thanks, Aisha. So it's this height here, and we see that it's 2. So I don't even need to write that down, honestly. You could even go from here and see that that amplitude is 2. So that one's really simple. It's almost like 3 marks. So I wouldn't expect actually to get that one. very often. It's too easy. Period, on the other hand, some students have trouble with. So you need to pick a point on the curve and then look for the same point somewhere else on the curve. So the easiest way to do this for this particular example is to look at the peaks. So I have a peak here and a peak here. Notice that that's the first time the function is repeated. I could have chosen this point and this point. Sorry, this is even though it's a sine function, it doesn't matter where you choose the points, okay? We're not talking about displacement here, we just need to talk about two of the same. This would be a period. You'll notice that if I was to move this, why is this an okay answer? Well, it's the exact same thing as choosing those points. In fact, I could choose these points. Look how they match. I could choose anywhere along this curve, any 2 points, because they would be the exact same point. It's just the beginning of a new cycle. The reason I chose these maximum points is because it's easy to tell what the distance is between them. So I'm going to write down that this is my amplitude. And what is the distance there? Well, by inspection, by looking at it, you should be able to tell that it's 4 pi. And the reason I know that is because I know that this distance is 2 pi. And if that distance is 2 pi and this distance is 2 pi, then in total, it's 4 pi. Another way that you can do this is you just look at the final position and look at the initial position, and it's the distance, or subtract them. Many ways to get the same answer, okay? So take the one that works the best for you. When I look at this, it's clear to me what the answer is. But for many students, they need more than one way. So, you know, get the distance from one point to the center and then from the origin forward. Or maybe just take this, I would recommend this way, final minus initial. Probably be the easiest way. Displacement is the third thing being asked. We don't have A, B, and C, so we need to get displacement. This is the one that messes people up the most. This is a sine function. So I'd like you to try and tell me what the displacement is going to be here. First of all, the sine function. We need to look at where the sine function normally starts. And we know that a sine function looks like this. Right? That's what our sine function normally looks like. We need to look for this point that's normally the y-intercept. For displacement, we need to look for that. So I'm seeing, Abdullah, you're saying negative pi? No, it is not. Because look at the difference between negative pi and how that starts moving. You notice how it starts by going under? That's not how sine starts. Sine always starts by going uphill. So that's not correct. We notice that it's uphill first. And so we have a couple choices. We have, no, negative 2 pi. It's not negative 2 pi either. That would be cosine. Cosine starts on the hill. What I'm saying is sine starts at a y value of 0 and then starts to go up, right? Sine goes, it goes up, then down, then back up. That's what sine looks like. So let me clear this up. Sine starts like this, uphill, downhill, back up. So it's either this one or this one. That is where I can start. I can choose that, or I can choose this one, or I can choose this one. Yeah, so it would be either pi is the distance. So it used to be here and now it's moving over to here. Or it used to be the center and now it's moving over to here. Both of these are displacement. So you have two answers for this particular question. You either have pi, which is the easier one to find, or you can go all the way to the left and figure out what that is. That would be negative 3 pi. If we go logically, 1 pi, 2 pi, 3 pi. So be careful with that one. That's the trickiest in my opinion. Most students, if they're going to get one wrong, that's the one that they get wrong. And on the assignment, many students got it wrong. Even my top students got it wrong. Not that it's all about the top students. I'm just saying that no matter who you are, you have a chance of getting this wrong if you don't follow it correctly. Okay? So 2 possible answers. In fact, these sine functions go on forever. So there's unlimited possibilities for what the displacement is. We just are seeing a little snippet of it. So we're not going to say anything else outside of that. All right, clear? We'll do one more. I'd like you to do the other one. I'm doing a lot more time on this besides the trig, besides the derivatives, because I want to make sure that it's clear. So use that as a reference and try to do this second question here. We need to note that this is a cosine function. So before you try this, cosine functions start at a maximum, come down, and then they'll come up before starting again. So tell me what A, B, and C are going to be. A, yeah, I see that you've written 3. Absolutely. Once again, I won't even keep this, but our amplitude is definitely 3 from the center line. In a higher level math course, we shift the center line, but in this course, we don't need to worry about that. As a small extension, in a future course, if you're ever asked to shift that center line, what you need to do is just find the top line, find the bottom line, take that distance and divide it by 2. That's the full definition of the amplitude. So if we were to shift that around, maybe I moved it up here and the center line was going through here, you would still be able to figure out what the amplitude is. But that's for another day. So amplitude is 3. What do we got? Period 3 pi? Let's see if that's correct. Period is, I would say the period is 3 pi. Yeah. So I don't know if you know how to use the annotation tools. You would need to go to view options. At least on a computer, it's click view options and click annotate. On a cell phone or a mobile device, you have to go to participants, I think. But can you just put a little point, put 2 points at the points that you use to find period? Because I'm curious what method you use to find the period. If you don't know how to do the annotation, that's okay. But they're not hard to find. Just pick through the menu until you find it. I'll give you a chance to find it. If you can't find it, I'll work on it. The answer is right, 3 pi. Okay, I'm just going to assume you're having trouble finding that. So the fastest way, in my opinion, to find the period, so there's 2 ways, Abdullah. You mean, when you say you don't know how to do it, do you mean you don't know how to get the period or you don't know how to do the annotation? Say good morning. Morning. Yeah. It's my class. I'm doing math. Red? We can't draw red right now. No, we can't because we gotta do some math. So we gotta go back down now, baby. We're gonna hold breakfast. Do some math. No. Yeah, that's how my students feel about it too. No. Okay. Me too. Any coffee? All right. All right, a little distraction. So let me show you multiple ways to find the period. The fastest way is to find the period is always the same. You find 1 point on the curve, just choose any point, and then follow a full cycle of the function until the next point. So I choose this point and this point. And the reason I chose those is it's very clear once you know what you're doing that this is a period, because it goes down, it comes back up to the center line. That's half a cycle. and then I go up and down, that finishes the story. I've got the full picture there. That's an entire cycle. If I was to keep going after that, it would start a new cycle. And I don't want to start a new cycle. So that distance is 3 pi. So Ayesha was right when she said 3 pi. Now, one thing I'll do, you don't need to write this, of course. I want to just make it clear here. This is my period. You don't need to write this part. I'm just going to move this around. You can choose any 2 points that are the same distance apart. I could have chosen those 2 points because that's a distance of 2 pi. You would have to do a little bit of math to figure that out, but you could figure it out. You could choose these 2 points for some reason. You could choose these 2 points. You could choose these 2 points, these 2 points. For example, if you chose those 2 points, it would be 3 pi over 2, 3 pi over 2 minus negative 3 pi over 2, which is still 3. You could choose the peaks, which in this case would be still 3 pi between them and so on. But this is the easiest one by far because you're starting at 0 here at the origin. You're starting at right at the origin, and you just need to read the graph. Sorry, I've got a weird setup here after moving, and I'm still working it out. Things are falling down around me. To find period, I just time that completes one cycle. Yeah, well, that's the first thing I said. I just wanted to make sure that we're clear here. Abdullah?
Yep. Sir, there is a question will be like a graph, and they say for me, give me A, B, C, or just A period displacement.
You'll be asked, generally speaking, you'll be asked to find period and displacement. Oh, sorry, you mean given the graph, find the equation?
Yeah.
I wouldn't expect one because I already gave one on the assignment. I'm not planning on putting it on the test.
Okay.
You'll need to sketch one, but you won't need to get it from the graph. Although if we needed it, of course, we could kind of work backwards from these points here. These are the most important pieces
Okay.
when you have the graph A, P, and D. So yeah, you said the find period. You see the time that completes one cycle. Yeah, find the time. Just whatever time it takes to finish one cycle. The problem is not the method. The problem is some students don't know what one full cycle is, and that was my big idea here. Okay, so 3 pi. Displacement, that one's a little trickier. You need to compare it to the cosine function. It needs to go down first. So I would look at either this point or this point. The easier one would be, let me make it red just to be consistent. This point or this point, I would say this distance here, which you need to figure out what that is. If you look at, my computer's being slow today, this is negative pi over 2. If you divide that in half, you get negative pi over 4. So that's the distance of each of these. So you go negative pi over 4 minus negative pi over 4 will be negative pi over 2. Subtract another pi over 4, you get negative 3 pi over 4. So that's actually my displacement here, is negative 3 pi over 4. If I go the other direction, this would be pi over 4, 3 pi over 4, 5 pi over 4, 7 pi over 4, 9 pi over 4. If you need me to review that, I can go through that again. So that would be negative 3 pi over 4, 4, 9 pi over 4. Again, with displacement, there's unlimited answer. There's infinity answers because this continues cycling forever. It's like an AC, you know how AC circuits work. Your electrons go forward, they come back, they go forward, they come back, they go forward, they come back, they go forward, they come back. Many, 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 many times a second. 60 times a second generally. All right, how do we feel about displacement? Once again, displacement was, you can have multiple answers. For period, just the one answer. Okay, let's move on. I won't do every question in full detail like this, but I wanted to have full solutions. 5 key points to sketch the graph of the function y equals 2 sine 3 pi, 2 sine outside of 3x plus pi over 2. So first thing that I would do is say that for a sine function, this is your structure. 0, maximum, 0, minimum, 0. And I can write that in already. I can see from the equation here that amplitude is 2, which means it should be 0, 0, 0. Maximum is 2, minimum negative 2. So you can fill in that table easily. The first point here is going to be the displacement. Right? This box here is going to be displacement. So I can get that first. Sometimes it's easier. Displacement, also known as phase shift. I'll get that first. That's negative c over b, which is negative pi over 2 over 3. I don't think you'll forget this because we just did this, but this is a, b, and c if we need it. So how do we get that? That looks to me like what? Let's see, pi over 2. So 1 over 2 divided by 3. I get pi over 6, negative pi over 6. Once again, the pi over 2 is like a group. Consider it like brackets. Then you divide it by 3. So it's actually a slightly different situation than we had before. Just make sure that if you put it into calculator, you use the brackets. It's negative pi over 6. That is what goes here. So I'll connect them with color so that you can see that. What's our next step? Well, to fill this table, the first value is always the displacement, for x, anyway. And then you add period divided by 4. So we need to get period, and then we'll divide it by 4, and we'll know what to add. This one's pretty easy. 2 pi over 3. And there's nothing else to do, actually. That's just the final answer. We need now to divide it by 4. So the period divided by 4 is, I guess, 2 pi over 12, or pi over 6. And this pi over 6, which I'll put in purple, is going to be what we add every time. Of course, all the stuff that I'm adding is just for you. You take the point, add this, put it back in, and follow our recipe. So the answers that pop out of this, you can try it yourself on the calculator, would be 0, pi over 6, and then it'll be 2 pi over 6, 3 pi over 6, 4 pi over 6, 5 pi over 6, 7 pi over 6. We just simplify our answers. So the next one is 2 pi over 6, but actually that simplifies to pi over 3. And the next one is what? 3 pi over 6, which actually simplifies to pi over 2. Which is why our answers simplify in this weird way, but that's just how it works out. I'm going to fill in my table here. My period was 2 pi over 3, and my displacement was negative pi over 6. So my table is finished. All I need to do is copy it down to my graph. Make sure I have enough space here. Okay. So that should be the easy part. The problem is I have a graph that has gaps. And so many students find it helpful to fill in those gaps before they start. So sometimes the easiest way to do that, in my opinion, is to find pi if you can, then go, how many gaps are there? 1, 2, 3, 4, 5, 6 jumps. So just divide it by 6, and this will give you this point here. So we have 6 gaps, so pi over 6 must be my answer. So this must be pi over 6. I'll write it in pencil. Pi over 6. The next jump is 2 pi over 6, so pi over 3. The next jump is 3 pi over 6, so pi over 2. This is 4 pi over 6. I'll fix these later. 5 pi over 6. That can't be simplified, so I'll write this in here. This is 6 pi over 6, which cancels down to pi, which is what's already there. This is 7 pi over 6, which can't be simplified. This is 8 pi over 6, which when you simplify becomes 4 over 3 pi, which is why we have this one. And then we have 9 pi over 6, which if we cancel this down should be turning into, I guess, 3 pi over 2. Okay, so that's how you do these. I don't usually write them out fully, but some students get that wrong, so I wanted to make sure that it was clear this time around. I'm going to erase these extra workings. And we have 0, of course, and then this must be negative pi over 6. So we've got our full story. Let's just copy out our table and we'll be done this question. And this was worth 10 marks on the assignment. It'll just be worth 4 marks on the test. Every long answer question is worth 4 marks for the test. So negative pi over 6 and 0. That's this. Then 0 and 2. Pi over 6 and 0. Pi over 3 and negative 2. And pi over 2 and 0. And connect these. Some students did this. That is not a sine function. This is a sine function we're graphing. We know that because it says sine right in the question. Sine is curved. It's a sinusoidal function, which by definition are curved functions. So they accelerate up and accelerate back down and accelerate up and accelerate back down. So this would be your sketch of the function. If you wanted to continue that, you know, you could. There's nothing wrong with that. It would look like this. But you don't need to continue that function. The cycle that the table gives you is more than enough. So that's how we do that question. Hopefully that was a nice review. Do we have any questions on that? Nope. Ahmed, Ibrahim. Oh, hi, Ibrahim. Didn't even see you there. Okay, so anyway, that's how we would graph this. Again, that should be just a review, but it was worth 10 marks on the assignment, the biggest question on the assignment. So I wanted to make sure that it was like crystal clear. Hopefully now it's crystal clear. If it's not, you can rewatch the video. So that's the end of the trigonometry stuff. That's the end of the Unit 3 content. That should be enough to get you through any of the multiple choice questions or even a long answer question. This would clearly be a long answer question for Unit 4. Now we'll start our review of derivatives, which should be very familiar because we just came off of doing that. So you should be like the derivative masters after this point and the limit masters after this point. Students did really badly on the limits on the tests, so I want to review them. I've got many, many, many questions here for you to do. I think maybe 20. Let's start with this table question. Use the limit to determine the limit as x approaches 2 from the right. So from the right, that's what that plus means. I'll just make it green. I don't know why I decided to change the color, who knows. From the right. So we look at our table and we can see that, you know, if we were to make a number line, you look at these numbers and you look at these numbers, they are trying to go to 2, which is why we have this 2 here. We can see that both of them are going to 2. On the left side, we have our 1.9. On our right side, we have our 2.1. And we're trying to creep in closer and closer and closer from the left side and from the right side. What we care about is from the right side. So really, to make it short, all we care about, because it's 2 from the right, we look at this, this is the closest value we're going to get to 2. We could always get closer. What number is it trying to get to? What number is that essentially? If we kept going with this pattern, it would be 6.00000000001. So in all fairness, it's really just going to 6 from the right. So the limit as x approaches 2 from the right of the function is 6. And that's our answer. If I asked from the left, it would be 5. If I asked the limit from the left, it would be 5. We don't need to know what this function looks like to give that answer. But this is how we do these, okay? I'm going to do 3 more of them so that they're crystal clear, and then if a test question comes up for this, you should be fine. So I'll keep that on the page so we can see and we can compare them. In the next question, it says, use the table to determine the limit of x approaches -1 from the left of the function. So -1 from the left, this is approaching -1, but it's on the left side of it. -1.1, -1.01, -1.001. I would look at this and then try to figure out what number that's going to. So the limit as x approaches -1 from the left is what? As this gets bigger and bigger and bigger, as we continue this process, it's going to be 99999, 99999, 9999999999999. What number is that going to? You have like a million 9s next to each other. It's a huge number. It's trying to go to infinity. It must be shooting up to infinity. The number's getting bigger and bigger. So it's infinity. So in this case, it was 6. In this case, it's actually infinity. You would not write 99999 because the whole point of limits is we're going to continue this pattern, figure out where it gets when it actually gets as close as humanly possible to -1. Some students get lost on the number line. So remember, we're trying to find -1. To the left side is -1.1. And to the right side is -0.9, because that's how negative numbers work. As we creep towards the right, we're actually going to get to our 0. Somewhere over here is 0. So take some time to think about that. Think about how that would work. Okay, so this is from the left. The other two I'm going to let you try. I'll give you the answers, of course, but I want you to give the answer to the first one and the second one. Who's saying 5? I'll wait for at least one other student to give me their answer. So Abdullah thinks 5 and then does not exist. Ahmed also says 5, and because there's only 4 of you, I'll go with that. Indeed, the first one is 5. That's because it's from the left, which I'm looking on the left side, and I should look at what value it's trying to get to. It's trying to get to 5. So that's excellent. Trying to get to the number 5. Anyone else have any, I'm not going to call it a guess, but anyone else have any answers for the second one? Only Abdullah has replied so far with DNE. Does not exist is what that means, DNE. So as you think about it, I'll talk about this. I'm looking at this limit. I see x is approaching 2, not from the left and from the right, but in general. So we need to look at both sides. So I look at this, I say 1.999. As x is approaching 2 from the left, the story it's telling is that it's trying to get to 5. But as x approaches 2 from the right, the story this is telling is 6. So the left-hand limit and the right-hand limit are not agreeing. Or in other words, this limit and this limit from the left and from the right are not the same. So if they're not the same, the limit does not exist. And we're going to see that graphically again in a second. But for now, I'm just going to say it does not exist. Okay, are we clear on that? Aisha, Ibrahim, and Ahmed, you didn't give me an answer for that. I'm not assuming that you don't know how to do it, but is it clear to you now that we've done it? Let's look at them all in one place. Okay, so this is our full story now. Hopefully that's enough to take a look back on later and make sense of what I'm doing here. And I did some of the notes as well. Let's go on to one of the questions, probably the worst done question on the assignment, which was unfortunate because it was supposed to be kind of an easy question. That's why I made it 2 marks each. But I guess it wasn't as easy as I thought. So let's make sure that we understand what to do. It says use the graphs to determine the limits. So this is all one big question. Let's get started. It says the limit as x approaches -2. Well, just look on your graph and find -2. This is x equals -2. And we need to say what's happening as it comes from the left and from the right. So you just look at it. I can see right away without any work that it does not exist. I know it doesn't exist because as I look from the left and the right side, the right-hand limit is going to positive infinity. The left-hand limit is going to negative infinity, and they're not the same. And if they're not the same, then that's all there is to it. The limits need to be the same for it to exist. So the left-hand limit and right-hand limit are not equal. From the left and from the right, they're not the same. The next question, I made a typo. Should say -1. So the limit as x approaches -1. We've got a little hole, but that doesn't matter. We, from the left, it's saying it's going to 1. From the right, it's saying it's going to 1. It's harder to write. Let me see if I can make that more clear. From the left side, it's going to 1, y equals 1. From the right side, it's going to 1, y equals 1. And so the limit does definitely exist, and the limit is 1. And before I go any further, you see what I mean? Because the rest of them are done the same way. Every single one of these are done the same way. They just look different. Don't let that fool you. Let's try some more. We'll keep them all here so we can compare them if we need to. All right, the middle one. You can try these yourself, but we're just going to power through so that the review doesn't get bogged down. The limit as x approaches -1, well, that's this line here. I can see that if I follow that line, this is one limit and this is the other limit. They're not the same, so it doesn't exist. For the next one, for x approaches -4, that's this line. I can see that they're both telling the same story. They're both saying it goes up, sir. It goes up very, very tall. And so I would say that this is going to infinity. So some students wrote does not exist. A limit of infinity is okay. We're allowed to have a limit of infinity. We're just not allowed to have limits that don't match each other. So be careful with that. We have the limit of infinity here. And if you want confirmation why, it's because as we go towards this x value, they both tell the same story. It's going up to this unlimited value. All right, my internet is dropping out for my other computer, so I'm just going to fix that. Tell me what the answer is for this third one. DNE, 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 DNE. So for -3, I agree it does not exist. What about for the next one? I'm seeing -2, -2. The limits, I mean, from the left hand and the right hand are the same, right? So it should be -2. That's exactly right. So it seems like we're getting this now. So I'll go through these quickly. I've got 3 more of them. I'm going to just write them all out. You can try them yourself. I'll just talk through it for those that are watching the video. So on the left here, we have x as it approaches -2. That approaches this value. That's 1, 2, 3, 4, 5, 6. Remember, the answer is 6. As it approaches 4, they're not the same. One limit, as it, from the left, it's a 3. From the right, it's a 1. So it does not exist. For my middle question here, as x approaches 1, that's this value. As x approaches 1, y is -1. And both sides can agree. The left hand and the right hand side say the same thing. The limit as x approaches 3 does not exist. The left hand says -infinity, the right hand says positive infinity. So they can't agree, then we don't have a limit. The limit as x approaches 1 does not exist. The limit as x approaches 3 is, this is x equals 3. So it would be the value 1, 2, 3, y equals 4. So that's how these are done. It's pretty easy, isn't it? In my brain, it's very straightforward. You just look at the left, what's the number? Look at the right, what's the number? If they don't match, it doesn't exist. If they do match, you just tell me what it's trying to go towards. So with this in mind, let me go to the assignment and show you that I didn't give you some sort of like trick question yesterday. The first question, the limit as x approaches -4 is infinity. The limit as x approaches -1, well, from the left and the right, they don't agree, so it does not exist. All right. Some of you wrote different things. Many students wrote 1 for the limit, but just because that dot is there doesn't mean that the limit is 1. Because remember, limits, when we do them, we need to check the left and the right. And it's all about if they agree. It's not really about what the number is at that point. It's about what the limit is, what the tendency is. Okay. Any questions on that before we go back into the more manual derivatives by hand? I'll take that as a no. Abdullah said no, so I believe the man. Determine the derivatives. What's the derivative of e squared? Many students write 2e. Right. It's 0. Why? E is a constant. So it's not a trick question. It's just a check for understanding. E is a special number in math. We don't use it for variables. We use it for a constant. And it actually has a value. It's used in higher level math. It's used in the same way as pi. It comes up in similar circumstances. It has a value, okay? It's just as special as pi is. Pi is a number that goes on forever, doesn't repeat, transcendental, all that thing. E is a similar number. We just don't talk about it as much because it's related to logs, and most people don't like logarithms. The average student doesn't deal with logarithms as much. So, long story short, the derivative of a constant is 0. Let's do the next one. This is 7 pi. Well, pi is a constant, 7 is a constant, so the derivative is still 0. So I could give you pi squared, I could give you pi to the power of a million, I could give you anything with pi. Just be careful. If there's no x, then it's probably all constants. An e or a pi, they're both constants. So let's look at the final one here. Y prime equals, let's see, sine of pi over 2. That's a number. You could calculate that. Sine of pi over 2 is 1. You could just put it in your calculator and say, is this a constant? Of course it is. It's a number. So that's a constant. Sine of 3 pi is a constant. Tan of pi over 3 is a constant. They're all constants. The derivative of any constant is 0, so the final answer is 0. The reason I'm asking this is maybe you'll get a multiple choice that puts something like this in there. And I want you to get that mark. You know, it's worth 3%. These are all constants. Okay. So I don't think I need to explain any more of that. I just wanted to prepare you just in case you get some constant work. If you need me to go back up, let me know. Determine the derivative of each function. We didn't get given very much space to do this. Maybe I'm trying to tell you that you don't need very much space. All you need to know is this is product rule, because we have a function multiplied by another function. So we'll do the product rule directly. Some students on their assignment wrote out every single step for the product rule. Nothing wrong with that, but it's not worth marks. You can do the product rule directly. But I know some students get a bit lost. But this, for most students, this is more than enough. So the derivative of the first one is 5 times 4, 20, x cubed minus 10. That's the derivative of the first one. This is g plus f for the first one, and then the derivative of g. Done. So on your test, because product rule is actually not complicated, and I don't ask you to expand it, it's going to, you should expect it as a multiple choice. I wouldn't expect it as a long answer question because they're not long questions really. You'll just still do it by hand and then you'll pick the answer that matches. Notice that even if these were backwards, it would make no difference. I don't know if that would matter. I don't think that'll come up, but just in case, some students like to do them in different order. So just make sure you don't get lost or mix those up or get confused. They mean the same thing. If the brackets are touching, same answer. So in this case, B prime. Similar story, but we have quotient rule, which is f prime g minus f g prime all over g squared. And let's just follow that recipe. Make a line for it. The derivative of the top. You should all be trying these on your own. I'm just working them out. but you should always try to practice on your own and check my work against yours. And if you get something different, please let me know. I can help you through it. Now we're doing the derivative of the bottom. 6x plus 4x cubed. And the bottom is really easy. Students were expanding it yesterday, even though I told you not to. I don't want you to expand this stuff. This is just take the bottom and squared. Some students thought the assignment was really long, which it was long, but they thought it was super long because they were expanding all the product rule and the quotient rule. That would take you an extra like 5 minutes sometimes. And I didn't ask for that, and I wouldn't ask for that, not in this course. All right, in the future courses maybe, but not this course. So just so I have a little bit of color coding the first time around, these are all related ideas. And finally, G prime G, G prime G, G, F. I won't do that for the rest. Can you type out what the answer to C prime is, please? I just need to take a short break. I need to get a little bit of water. But tell me what this one is. I'll give you a hint and tell you its chain rule. And I'll be back. Anyone get it? Perfect timing. Let's see, 3 outside of 3x squared minus 4x, 6 minus 4, power 2. Tricky. You did the same thing last time. Don't forget that power 2. But you caught yourself, so it's good. Derivative of the outside, keep the inside the same. So I'm going to do what I like to say. I keep the inside the same. I know it's going to be the same. I do the power first because if I don't write this power in now, there's a really good chance I'm going to forget it, especially if you're really concerned about copying and all that, and then doing the derivative of the inside. Many students forget that power. It's a very common mistake. So just be careful with that. And now we do the derivative of the inside, which is 6x minus 4. So in summary, we do the power first, which brings it down, reduced by 1. That story's finished. Keep the inside the same. That's easy. And then we take the derivative of the inside, which pops out next to it. All right, take as many steps as you need to do that. But I've given you a small space just so that you know it's a small answer. It's a one-step question, or at least a one-line question. Okay. The rest of you, are you okay? Do you want me to go through anything? You're just chilling? I can stop asking you questions. Just if it's all good, just say all good, and I'll stop picking on you. And I'll just assume that if you want to ask something, you're going to ask something. Okay? I get all concerned about my students, you know? I care. But if you have a question, let me know. Okay? I'm just going to go. I'm going to go. So once again, this is product rule. We'll write out the answer. Same exact steps as before. You can follow me. Derivative of the first one. Keep the second one the same. Plus the first one. Derivative of the second one. That would be our answer. The only issue is you need to be very careful about the derivatives themselves so you don't make a mistake, but that's all there is to it. This one I can see it's a giant quotient, so it's quotient rule, the derivative of this. Just the derivative of the top, 6x squared minus 4. The bottom, top, bottom. Almost made a mistake there. And then, isn't that great? I can stretch that out. I never, ever, ever can think ahead well enough to get the line the right size. So technology is the best. Just like this, I always mess up the distance. I like to have things centered. So I'm like, hey, yeah, this feels right. Moving that there. So if you get the chance, get a surface. That's easy to say. Get something that can use one note because it can help you take nice notes. And if you had OneNote, I could be sharing all of my stuff with you and you can see it live. And you can go back through, scroll back through all my notes as I'm talking. It's pretty sweet. Okay, the last one, chain rule. K prime, x, derivative of the outside, keep the inside the same. Now I'm going to do the derivative of the inside. If you don't write in these brackets, I should have said this earlier, if you don't include these brackets, you lose a mark. And the reason for that is that it's not the same. We're not just multiplying it by the first term. Oops. We're multiplying the entire expression. This is the problem with technology sometimes. All right. You're multiplying the whole expression by that. So it's this multiplied by this multiplied by this, which is why when we simplify it, if I wanted to, I multiply 3 by all of this. Both terms, 3 times 2x, 3 times negative 2. So just be cognizant, be aware that you need to be thinking about that. Make sure you have the brackets. What the heck is this? This is chain rule and quotient rule. I see one big power of 3. That means it's still power form, but the inside function is its own thing. It looks very complicated. Honestly, if you know what you're doing, if you're careful, this is actually very simple and it's very easy marks. So maybe this would be a nice question for a long answer. So derivative of the outside, keep the inside the same. So I'm going to rewrite the inside. That's the entire chain rule done, really. I mean, that's the hardest part. That's the only difference. I've done the derivative of the outside, kept the inside the same. Now I just need to get the derivative of the inside, which is something I did earlier. I mean, once you've done this step, this part's easy. Just deal with this only. All of that. This is just its own problem. Don't worry about anything else. Don't worry about touching the outside powers or anything again. You're done with that. Just do a fresh quotient rule. So this is the derivative of the top. Times the bottom minus the top, the derivative of the bottom, all over the bottom squared. So this is just the derivative of that pink part. I guess you could call that pink. So the beginning part is sort of our chain rule part. This part here is sort of our quotient rule part. It's not quite how it works, but that's how you can think about it. All good? This looks big. I would argue that it's actually very simple and looks impressive. You know, you can hang it on your wall and be like, yeah, I remember when I did those big math problems. But really, they're surprisingly straightforward. Let's do the next one. This is also a mixed derivative. I'm going to need to do chain rule, but in this case, I need to do product rule because it's two chain rules multiplied together. So let's take it piece by piece. This is going to be, this is really product rule, and the chain rule comes in as part of that. So the product rule and then the chain rule to be considered here, because this is our first function, this is our second function. So let's see what we got. The derivative of the first one is 3. Keep the inside the same. And then the derivative of the inside. Okay, that's the derivative of the first one. That's f prime. Now, that's the first step of the product rule. The second step is to multiply by g. That's g. Plus the first one as it is. Now I'm going to do the derivative of the second one, which again is another product rule, but I wouldn't call it difficult, just takes a little bit of time. At 11, copy the inside. And then get the derivative of the inside. I ran out of space a little bit there, but, you know, these things happen. I'm just going to tidy this up, but let me know if that makes sense. I can go through any of the steps again. Okay, hopefully that's clear. That's a nice one because it looks big, it looks complicated, but really it's just a couple different questions in one. And if you're careful, you should be fine. So we've only got 2 more pages left, and they're not all that difficult, really. We have a couple questions repeated. We're almost done the review. So if you're feeling good so far, you should be very well prepared already, even without doing your own review, to take on the test. I'm not going to say that this is enough review for the test. This is really good review for the test. In fact, if you understand all of these concepts so far, you should be on your way to an A, for sure. But be careful. Make sure you go through the notes and you know, redo the assignments, things like that. Determine the derivative of each function. Okay, well, this is going to be implicit. That's pretty clear. I can see it's implicit. I'll write the same thing I always do, which is I see that there's y's mixed in here. Thank you. And I'll just do the derivative step by step. So if it has a y value, if you see a y in the middle, the only difference between a y and an x is when you get the derivative of y, you get a y prime value as well. The derivative, I'll just do step by step. So I have my y prime value here. That's the most important part. That is the whole point of the implicit. And when I say implicit, really the difference is that it gives me a y prime. Now I've got a product rule that's sneaking its way in, which I know Abdullah catches every time, so I'm sure he's thinking, product rule. But yeah, I knew you were going to write it. Product rule. And I'm actually not going to even write all that extra. That's just my product rule here. So the derivative of the first one times the second one plus the first one times the derivative of the second one, which is y prime. So that's where my second y prime comes from. The 3 is a constant, the 0 is a constant, so this is all 0. So I'm going to bring everything that's not touching a y prime to the right side, and I'm going to factor out the y prime. So I'll do the right side first. I can see that the 24x to the power 5 is going to move there. I can see that the 4x cubed y is going to move there. That's getting rid of these. I'm not going to keep those dashes there. They don't actually cancel. I'm just moving them over. They move over to the right. So, you know, just maybe to help you, that can move over and that can move over. What's left? I have my y prime. I'm going to factor it outside. What's left is negative 15y squared plus x to the power of 4. Those are the terms left over once I've factored out y prime. So many students find it helpful when I highlight these. So why negative 15? I don't know. I made a mistake. And I'm glad you're paying attention. Plus, my bad. I don't know why I had a negative. There's no answer to that. Thank you for catching it. Now all I need to do is divide. Y prime is my whole right side divided by the factor on the left side. Students have a whole lot of trouble with these, but once you understand the steps and you figure it out, oftentimes it's a really good way to get 4 marks on a question. Full marks on a question. Because there's not much to it. One of these days I'll make perfect boxes. Okay. By the way, on this, you can make it make boxes for you, but I feel like it's too nice. I like to have a little bit of character in the notes. If I wanted a computer box, I would just let my computer do everything for me, but I like to have a little character in there, a little bit of soul, you know? So we feel okay with that? I want you to try the next one yourself. The next one has a little trick. And by trick, I just mean, well, I'll let you figure that out. I'll make one little note. You're going to have to consider what to do with this 3. Okay, so try this question, you know, take 2 or 3 minutes, and then I'll write out what my solution is. So I changed my mind. I don't want you to go too far into this because you might end up getting the first step wrong and then the rest of it wrong. So I'll just show you the first step. What I would say you should do, there's many ways to do this. You can factor out 3, but the best way to do it, in my opinion, is to take that as your first piece, take this as your second piece, because it's a product rule. Let me show you what that looks like. The derivative of the first one now is 9x squared times the second one, plus first one times the derivative of the second one. And once you have that product rule done, you should be able to, oh, Abdullah's got something already. You should be able to work out the rest. So now that I've got that, I'd like just a few of you to write it in the chat. Tell me what you get. That should be about enough time. I'll work on the rest. Let's see, 28 y cubed times y prime. I'll factor out the y. Hopefully I didn't do any weird negative problems this time. Looking at Abdullah's, I can see that he is not right. You're missing a 15x, unless I did something wrong, Abdullah. This is my answer. So let's see, you had negative 9x squared y. Yeah, minus 15x squared. I don't see your 15x squared anywhere, but the bottom looks okay. Your bottom is fine. I'll center these a little better, but hopefully these are clear. I would say that they're not difficult. They're a very nice, easy way to get 4 marks. And if I were to give it as a, oh, sorry, I was writing that whole time. Sorry. Let me just quickly recap. Factor it out, move the other ones to the right side, and then divide by that. I forget what I was saying. So, oh, I expect it as a multiple choice. It'll be a 1-mark question, but the implicit function will be much smaller. Okay, so don't expect it to be given as a long question again, because I did that in the assignment. But I want to test it just a little bit on the test. Excuse me. So just be expected to be able to do a small one, like, I don't know, maybe something like that. I don't know. Solve that for y prime sort of thing. Let's keep going. We're almost done. On the second last page, evaluate the second derivative of this. The most important step is the first step. What would be the most important thing to do here? You can get the second derivative of this pretty easily, but you can make it really easy on yourself. You don't want to use quotient rule, do you? You want to rewrite it. you definitely want to rewrite. You want to make a new form. Y equals, keep the constant, bring the bottom up on top. We need to use brackets. And because we brought it up top, we need to make it -1 on top. We need to make it a power of -1. But now that we've done that, it's really simple. We've made a chain rule instead of a quotient rule. So let's get the first derivative. It's going to be -256. Keep the inside the same. Reduce the power by 1. And then get the derivative of the inside, which is just -1. So in other words, our y prime is 256, 512 minus x to -2. I want to have the second derivative now. You didn't need to simplify that -1. You could keep going. But it's easier if you simplify it. The second derivative, because it's saying evaluate the second derivative. So I need to get the second derivative and then put x into it. Second derivative, same story. Bring the -2 down, it becomes -512. Keep the inside the same. Reduce the power by 1. The derivative of the inside is going to be the same as it was before, which is -1. If it was something different, if this is a different question, you would still have the same derivative of the inside. That's why this way is so nice. And then our second derivative is 512. So when you do a few of these, you can see that you can skip steps. In fact, I'm going to move this down on bottom. The 512 is on top, and then the 512 minus x is on bottom with a power of 3. My last step, when x equals -8, y double prime is going to be 512 divided by 512 minus -8, which is, I'll calculate that in a second, but I just want to give myself more space so that it looks better. What's that going to be? It's 520 cubed, 512 divided by that. I get something weird, but I think this is the answer. Which in other words is 3.64 times 10 to the -6. So that's a tiny number. Definitely better to keep the fractions. Is that okay? Did I make any mistakes? I hope I didn't make any mistakes. I did one just like this, I think on page 45. All right, long story short, if it says evaluate the second derivative, you need to get the second derivative first. You can't evaluate something that you don't have. So find the second derivative, then we put in -8. Easy peasy. I would say the most important step is to rewrite it first. So I'm just going to move this up so that it's a little bit clearer. And let's continue to the last page.
I think this question will be not multiple choice, right?
Correct.
Okay.
Good thinking. But too much work for a multiple choice. Given the function.
Actually, how much multiple choice we have?
10.
And short questions?
5.
5, okay.
So you can probably start to work through the review and see how I've built this. You can probably say, hey, maybe multiple choice, maybe a long answer. So in this case, we have 2 parts, which almost definitely would be a long answer. Given the function, calculate the slope of the tangent line at this point. And then the second step is to find the normal line. So I'm going to do this quickly. I'll write out my normal steps. First step is get the derivative. And this second step would be the sub in the x. So the first step, the derivative of this function is negative 6x plus 2. To substitute in x, I'm just getting the slope of the tangent line. Read the question carefully. Just the slope, just m. So the question is really, what is m? So if I evaluate the function, I put 2 in. That's negative 12 plus 2, or in other words, is negative 10. That is our answer, but just so it's clear. Slope of the tangent line is 10. Now that we have the slope of the tangent line, we can easily find the slope of the normal line. So this is like, we need to get negative reciprocal at this step. So in order to get the slope of the normal line, what do? We take the tangent line slope, flip it over, and change the sign. So it becomes 1 over 10. And then we need to use y equals mx plus b. Our y value is negative 8. Our m is, of course, 1 over 10. Our x is 2. And we're looking for b. Move that over. That means we have negative 8 minus, this is 2 over 10, which is 1 over 5, so minus 1 over 5 equals b. What's negative 8 minus 1 over 5? What's negative 8 minus 0.2 in other words? It looks like it'd be 41 over 5, but let me just double check. 41 over 5, negative 41 over 5. The b is important. Let me just recap so that you all know what I'm doing and why I know how to do it. First step in the a was to find the slope of the tangent line. That's easy, or it should be if you understand. The derivative is the slope of the tangent line. So you get the derivative, put your number in, that's your slope. The second part, determine the normal line, we need to have that extra step. We have the slope already. We get the negative reciprocal, and then figure out the equation of the line using y equals mx plus b. So y equals something x plus something. Well, the m is 1 over 10. And then plus b, well, it's just minus 41 over 5. I saw some students writing plus minus negative numbers. Like, there's no need to write a plus minus. If you're adding a negative, you are subtracting. That's what you're doing. So let's see. Second derivative plus normal line will be short question. I get 2 out of 5 short question. Okay. Well, you're on the right track. Remember, we had to sketch a trig function earlier too. That probably wouldn't be a multiple choice. So don't forget what we did earlier. We did the sketching. That would definitely not be multiple choice. Okay, that's our normal line. I could graph that if I wanted to, but I don't want to right now. I've done that enough. The position of an object is given by this. What is the velocity of the object after 2 seconds? All right. Well, we know that the position is s of t. The velocity, let me be crystal clear here. The first derivative of the position is the velocity. And that's 15 t squared plus t minus 6. That means that velocity at 2 seconds, just so I'm clear here, 2 seconds, I'm putting in 2 as my value. It's 15 2 squared plus 2 minus 6. And this will give me my answer. I'm just going to make sure the colors match. So this is 15 times 4 plus 2 minus 6, 52. And it's meters per second. I can tell that by the context. If it's talking about seconds, we don't usually talk about kilometers per second. It's a speed or a velocity. So you can write the units. They're not worth marks, but they're a little like, hey, I got you, Mr. Scott. I can figure this out. So the first derivative is the velocity. That's your trick here. It's not a trick. That's your key. In the second step, it says at what time, so we're looking for t equals something, does the acceleration of the object reach 80 meters per second squared? So we know acceleration. So let's just pick this up. The second derivative is the acceleration. So in a similar way as we saw before, the first derivative is velocity, the second derivative is acceleration. I'm going to get the derivative of this now, and it will be my second derivative. All right? I need to find time when the acceleration of the object reaches 80 meters per second. Let me rearrange this. I know that time was unknown, but I know that my acceleration is 80. Okay? The acceleration of the object is going to be 80 meters per second. I need to know what time that happens. So we just substitute in 80. We can say I'll say A equals 80. So I have 80 equals 30t plus 1. So that's 79 divided by 30. So time must be 79 divided by 30. I just want to know if the fraction is nice. It's not. 79 over 30 seconds, which is an ugly answer. No one would ever say that. No one would ever give time as that. So what you should do is probably give it as seconds, but I'll take both. This is 2.63 seconds. Okay. So long story short, if you're given position, get velocity and acceleration derivatives, and then work with the information that you have to solve it out. If you've done physics or similar courses, you're doing engineering, this should be a very, very simple question for you. And I don't mean that to say that, if you're finding it difficult that you should find it easy, but this is not what I would call difficult. There are questions I would call difficult. This isn't one of them. All right. I'll do this last question, and then I'll recap the review, maybe give you a couple hints, and then we'll be done. The position of an object, s of t, is given by this. What is the velocity after 3 seconds? So we're looking for v of t. We're looking for v at 3 is really the answer here. So first things first, the velocity is the first derivative, which is 6t minus 5. Hey, didn't I have that before? Looks familiar. If that's our velocity in general at any time, then our velocity at 3 seconds is 18 minus 5, or in other words, 13. And I'll write the units just to be fancy. 13 meters per second, or about 47 kilometers per hour. Last step, what is the acceleration? I told you already that the acceleration is the second derivative. So we get the derivative of what we had up here. That would be 6. Huh. So the question said we're looking for acceleration at 5 seconds, but our derivative here is saying a is a constant, or a is 6. So I guess the acceleration doesn't change. This object must be in what we would call constant acceleration or uniform acceleration. The final answer is itself. And so there we go. I'll say regardless of t, or I'll say t doesn't matter here. Let me rewrite it different. for any time t? I'm trying to think. You know, obviously English is my first language. Most of my students, it's not. And so I always try to think, when they read back on this, will they understand the words that I'm using? And I try to do the same thing when I'm talking. So I hope that I'm talking at a nice level that you can all, you know, I like to hope that you can understand everything that I'm saying. Inshallah.
Mr. Scott, if I forget m over s squared, I will lose mark or mark
No.
or like that. Okay.
No. The
Okay.
meters per second squared is just optional. That's like extra. If you are doing this in a physics course, generally speaking, your standard units are meters and seconds, but you don't. That's not worth marks. I'll write that down clearly. I'll say no need to include units. Just so I'm clear, you don't actually need to write that out. I'm just writing it out to connect it to physics. So I'm sure you've done physics. Okay, let's go back to the top. I'll give you a couple hints maybe, and that'll be good for the day. And you should be, you know, feeling good about going into the test on Sunday. There's lots of practice left online you can do, but for now, I think I've covered everything that I wanted to cover. So let's see. First question was, what is the amplitude, period, and displacement? That would be a good multiple choice question because I'll ask you period or displacement, and that'll be enough. I don't need to ask all three, I'll just ask you any. So going into the test, you don't know which one you're going to get, so you just need to be prepared for all of them and you're all good. Second question, same story. I'll give you a graph. I'll either ask you period or displacement. I'm almost definitely not going to ask you amplitude because it's just too easy for a question worth so much. So period or displacement is what you should expect. Multiple choice. Sketching the graph is clearly not going to be a multiple choice. I would have to be a very angry man to give that to you. So this would be a long answer, but also only worth 4 marks. So your main components are important. So maybe 1 mark for the table, 1 mark for the graph, stuff like that. Use the table to determine limits from left and right. That I would expect would be a multiple choice. Given the table, choose the correct answer. Given a graph, find the limit. That again would definitely be a multiple choice. Given the graph, find the limit at a given point. Determine derivatives. That would probably also be a multiple choice because it's a very short question. Determine the derivative of each function. The basics, the product rule and quotient rule, I would expect as a multiple choice. You obviously need to be able to still do them, but the structure is very simple, so you should be able to handle it with a multiple choice. Same thing with chain rule. The mixed derivatives, because they're long, would be more likely to be a short answer, or in other words, not multiple choice. Got that, Abdullah? The derivative of the function, if it's implicit, that would be a slightly shorter question. You could expect it as a multiple choice. I don't know what the questions are because I'm actually not making most of this test, but I know the subject matter. So this would be, you know, I'd expect a multiple choice, but of course you need to know how to do them anyway. Evaluate the second derivative. I would expect that to be a long answer because there's first derivative, second derivative. If you make a mistake along the way, I want to be able to give you marks. So that would be a long answer question or a short answer question. Given the function, find the slope of the tangent and the normal line. That I would expect to be actually a multiple choice and possibly a long answer. And the reason for that is the slope of the line is very short. A very short question makes a really nice multiple choice. Get the derivative, put in your x value, done. That's very short, would make a good multiple choice. Getting the line itself, so getting the tangent line or the normal line, is a better question for short or long answer. So what I'm trying to say is if I'm asking for the slope, it could be a multiple choice. If I'm asking for the equation of the line, I would expect a long answer. And then the position function questions where you get velocity and acceleration, that's a long answer question. And that should be an easy 4 marks. I'm not trying to make this difficult. This question, I do know what you're going to get, so you're well prepared. Okay, and that's the end. So I'm going to stop the review here. And if anyone has any questions, I'll answer after the recording. But good luck studying, everyone, and I'll see you on Sunday.